Good morning, everybody. So let's go ahead and take a look at our week 3. So week 1 and 2, we spent a lot of time solving inequalities. So that's what I want you to have down. You should have a problem like 2x plus 3 less than or equal to 5, and you should be able to get the final answer without an issue. All right, if not, be sure and talk to your teacher, come to office hours, or come see me so that we can get those questions answered. This week, we're going to focus on absolute value. All right, so if you could take out your packet and turn to page 17 or have page 17 open. All right, so that's what we're going to take a look at this week is solving absolute value equations and inequalities. Today, we're just going to focus on equations. All right, so before we get started, like I said, one of the problems that you should have down are these. What I'd like you to do is go ahead and solve it and put your answer in. All right, let's see how I solved it. So first we got to find a boundary point. We do this like normal. Minus 7 from both sides. That's going to be 3, 4, 5. Divide both sides by 2. So x equals 5 halves. All right, do I include the boundary point? Since this is the symbol and there's no bar under there, it's going to be an open dot. So then I'm going to put 5 halves right here, make it an open dot. The question is, I don't know which way to shade. So what I'm going to do is test a point. I'm going to test 0. I'll do that in another color. 0 is to the left of 5 halves. So 2 times 0 plus 7 is 7 less than 12. That is true. So I'm going to shade in this direction. So my final answer is x is less than 5 halves. Notice, this is part of my answer. It's not the 0, it's not anything else, it's not the 7, it's not the 12, it's this point here. Okay, so why do I shade this way? Because that's where all my true values are. So no matter what I plug in on this side, it will always be true. All right, so today's topic is on absolute value. So one of the questions we had for homework was something like this. The absolute value of some number equals 15. So what could x be? Well, I can plug in 15 and I'll get 15. So 15 is one of my answers, but so is negative 15, because absolute value talks about the distance from 0. And they actually say it right here. The absolute value can represent the distance on a number line between that number and 0. So if I want to know how far, what are the values, I think about it like this. I want to know 15 away from 0 is going to be 15. It can also be negative 15 because I can go in this direction. So I have 2 answers. So that's, I believe you've seen that in middle school. What you're going to see, what's different this year is that it's going to involve an equation. All right, so now I'm going to ask the same question. What are my 2 possible values underneath my finger? So don't worry about what it says under there, but what are the 2 answers? Well, on this one, if it's 15 and negative 15, underneath my finger has to be either 16 or negative 16, right? But I don't have an X under my finger. I have an actual expression. So in other words, 3x minus 5 has to be 16, or 3x minus 5 could be negative 16. So with an absolute value equation, I have 2 possible answers. Let's go ahead and finish solving this. And you can verify if that works, right? 7 times 3 is 21, minus 5 is 16. That says 16, by the way. If I want to check this one, the 3's will cancel out, so I'll have negative 11 minus 5 is 16, negative 16, but the absolute value of negative 16 is just 16. So just a quick check, what's the absolute value of 8? What's the absolute value of, or negative 8 is 8. What's the absolute value of 8? That's also 8. So all it does is it looks how far away from 0 it is, right? Just a recap. All right, let's look at number 25. Or we just did 25, number 26. So here's an opportunity for us to take a look at what absolute value means in context of a story. So here we go. Henry is riding his bike along a straight road when he gets a call from his mom asking where he is. Henry says he's 7 miles away from home. Below is a number line representing the road Henry is traveling along. Okay, so we're going to place Henry's home at 0. Then mark the position on the road where Henry could be when his mom called. All right, go ahead and do that. All right, it says he's 7 miles from home, so he could be here or here. That's it, right? Okay, so now if I want to write an equation, what do you think that's going to look like? Yeah, it's like what we've been doing. Right? Because what are my two possible solutions? X could be 7 or X could be -7. Done. These are my two possible values. All right, let's take a look at the next one. All right, Henry continues along his route when a friend Emerson calls and asks him where he is. Henry says, I'm 3 miles east of my house. So this is west, this is east. So he's 3 miles east of his house. Great, says Emerson. I'm just 2 miles away. So Emerson is 2 miles away. So 1, 2. He could be here, right? Or he could be here. So now the question is, what would this equation look like? Because now I'm no longer at 0. And so let's take a look at the possibilities. I know my answer needs to be 2, right? Because it needs to be 2 miles away from there. But the problem is this isn't at 0. So what if I just shifted everything back? How many spaces do I need to go back? I need to go back 1, 2, 3. Because if the home was at 0, I would be 3 backwards. That's exactly what goes here. It's just 3 back from there. This is kind of, you'll learn a lot more about this next year, but this is this idea of shifting things back to 0. That's what this is doing. All right. So let's do it algebraically, make sure that we're right. So our final answer should be 1 and 5. So what do I know? I know whatever is underneath my figure needs to be either 2 or -2. So I know my answer is going to be 2 or -2. What do I write there? X minus 3, X minus 3. If I just solve it, add 3 to both sides, X equals 5. Add 3 to both sides, X equals 1. Good, the answers match. And that's what I expected. So this was kind of cool. We went from a situation to an equation, and then we solved the equation algebraically to confirm our understanding on the graph. All right. If you have any questions, please type it in at the end. All right, and make sure you finish the Edpuzzle all the way through so it shows that you finished it. All right, talk to you later.